Yesterday we have stopped at that creation of that opaque views in physical layer, right? Okay. Now let me open that file yesterday. What we have created. Okay. This is the file that we have created yesterday here, right? Okay. Yesterday we have been stopped at this place. I'm sorry, guys. What is the problem that has arisen yesterday is yesterday that was my mistake only. Yesterday I have created this what we say created this opaque views, but I have created a table, but I have not created the structure for that table. Actually, what I mean to say is I have provided a table name and I have created a table, but I failed to provide column names to that particular table. What's happening in the background is this OBI it is not having the particular defined structure of this metadata structure of that particular columns to display that particular columns when we click on that view data, and that is the reason why it's it's throwing up with an error. Okay, let me show that to you once again now. Let us say if you want to create a duplicate table for this, let us say customers. I'm going to click on new object and I'm going to click on this physical column. Sorry. New object, and I'm going to click on duplicate, but as duplicate option is not available over here, what I will be doing is I will be clicking on this copy button and I will be pasting that. Okay, now customers duplicate is available. Now what I am doing here is I am renaming that particular table customers opaque view. Okay, I am renaming this to this particular with this particular name. After renaming, actually I'm duplicating this particular table from original D1 customers to table. Okay, as I'm duplicating this entire framework of this table is also available in this table that we have created now. Okay, the entire framework of structure will be available. If you want a proof for that, see the entire column structures have been imported. Now if you create a opaque view with a query, why? Because we have imported the same entire structure, right? Now let me select a few columns from not few columns, as I have imported all the columns over here. I need to make use of all the columns. If I want to make use of all columns, I need to provide a select query. Select star from D1 underscore customers to where region equal to, say, let us say central. Okay, now in this customers to table only we will be having customers details where for region central. Okay, for all the remaining regions data should not be visible for us. That is a query that I was providing here for this particular view. Okay, all the all the columns will be the same, but it will be filtered based upon the particular region. Okay, I'm going to check that now. The moment when I click on this OK, this physical table will be converted into the form of an opaque view. That is, we will be getting this spectacle symbol over here. See, now I got opaque view symbol over here. The moment I click on update row count, it failed. Why? Because there would have been a fault in my query, because I'm not aware of this exact column names. I have given it blindly. Let me design that query over here in this particular database, and then let me continue. D1 underscore products. select star from d1 underscore products where shit d1 underscore customers. Customers 2. d1 underscore.
Customer. Only customer.
No. It's d1 underscore customer 2. Yes. That is a mistake I have provided there. Where region equal to its capital C and central. Now the query is ready. I'm going to paste this particular query over here. See, I have provided this wrong name over here. That is the reason it thrown up with an error. Okay. Now what I have done is I have used the same structure of the duplicate column, because if I want to create a view with only some particular columns, then I need to provide the column names over here, and I need to remove all the remaining column names over here, because there should not be a structural mismatch between the things that we are querying and that things that we need to display. Okay. The structure should be same. Let us say if we want to import only 3 columns, then we need to have only 3 columns over here for this particular table. Yesterday what I have done is I have just created a table name, but I have not created any kind of columns or anything, and that is the reason why it has thrown up with an error. Now let us check whether this is correct or not. Now, okay, I have created with the absolute query that is working. Now I am going to update row count. The moment when I click on update row count, see, row count got updated, and now if you click on view data, and even the view data is also available. Okay, it's working perfectly now. This is fine for everyone, right? This is how we can create opaque views. But as per OBI best standards, it is highly recommended not to use opaque views. If the business is demanding, and if you want to use that and you have no other go, then only it is recommended to use this opaque views, or else it's better to import tables, and it's better to work on direct physical tables only. Why? Because we are creating additional load on this BI server with this opaque view. Why? Because initially what it used to do is, whenever some query comes from this business model layer to this physical layer, what it needs to be doing is it will be just checking the addresses in the physical layer, and if a physical query gets generated, and that query is going to get placed into the database, and whatever the query processing, the entire query processing used to take place in database end, not in OBA server end. But here, as we are providing query dynamically over here inside this Oracle BI interface, initially this query is needed to be processed by Oracle BI server, and then that processed query will be going to this physical database, and the data will be fetched from there. Here we are wasting our time in additional processing by using these opaque views. So as per BI best standards, they recommend not to use these opaque views, but as a concept it is available, and as a trainer it's my duty to convey that to you. Okay, by this we have covered up all the options that are available in this physical layer. Okay, now let us move on to this business model and mapping layer. Let me delete these things. A business model and mapping layer, this is very important layer in OBI. Let us say if they have given 10 days for you to develop a project, that is they have given 10 days for you to develop an RPD, you will provide your work efforts in such a way that 8 days I am going to work on BMM layer, and 1 day I am going to work on this importing tables, that is importing tables into physical layer, and 1 day I am going to work on this presentation activities, that is in presentation layer. Because in a project you are going to allocate around 90% of time for designing this BMM layer, because the entire business is going to get, get a lot of improvement, or let us say this entire business depends upon reporting work depends upon this design of this business model and mapping layer only. Now initially let us create joins between these alias tables. In order to create joins, what we need to do is select all the tables. Okay, right click, go to physical diagram, select objects and all joins. Okay, as we have not created any joins, that joins will not appear over here. In order to create joins, we have a join button over here, new join button. Okay, click on this new join button, and always our direction will be from our query triggering will be from fact to dimension, right? So click on this fact first and click and drop it on any dimension. After clicking on the fact, we need to provide a common column for that. That is, in customers it is like cust key or something, new key. Okay, here it is cust key. Now the physical relationship between these two tables has been created over here in this expression. Okay, if you want to do any kind of manual operations, even you can do that kind of operations over here. Now from this table to this table, for this it is like IYMMDD and period key, and between these two tables the relationship between these two tables is product key, and here it is prod key. Okay, all these relationships will be provided to you in real time through a data model diagram. You can request the client for a data model diagram. Data model diagram is nothing but they will have all the columns, sorry, tables with described with all the columns, and they will be having a relationship. It's just like a kind of block diagram. I will show you how it is available in real time. It is called as data model diagram. See, this is how a data model diagram looks like. Okay, here I think it is completely, these schemas, they are like they are using completely normalized tables. It may be like in a OLTP database, but in OLTP database we will be having a central fact table, and we will be having many corresponding dimension tables that is present around that fact table. Okay, if you request your client for a data model diagram, then they will be providing you with the data model diagram, and they will even be having keys defined on each and every column. See, let us see here. Here this is the key. Okay, all keys will be defined with some key symbols, and a relationship exists between each and every table. Okay, this diagram they call it as data model diagram. By that you can create joins in your project. Okay, now I have completely created joins for all the physical tables that I have imported. Okay, sometimes it's better to create keys even. Some, as we are not importing keys, as we have joined this table to this table, it's identifying that is the only key that is present in particular table. So here keys have been created automatically over here. It's better to create a keys on your own even. That is okay. Here the keys has not been automatically populated here, right? Now I will be showing you guys how to create keys manually. That is how to define keys for yourself. Here we are having keys like prod key. You can provide your own names to your keys in OBI over here. This is just like an identifier, and actually the key would be you need to select that particular key from the list of columns that are available in a table. For prod key it is prod key, and for period key it is period key, and for customer it is cust key. It is cust key. Okay. We have defined keys and we have defined all the keys over here. Okay. The moment we click on OK, see, key symbol got populated for all the columns that we defined them as keys. Okay. Perfect. By this step, we have completed all our work in physical layer. See, we have created a relationship between all the tables that we have provided a relationship how each table is connected to the other table. Okay, our entire work is completed in physical layer. Okay, let's have a quick recap. I just want to know whether how you guys are understanding. Okay, can you people say what are the activities that we do in physical layer? Are you guys there? Okay, importing metadata. Next. Harish, are you there?
Yeah.
What are the activities that we do in physical layer?
Physical layer, first of all, we'll open a connection tool and we'll get the metadata of all schemas which for whatever we require,
Okay,
and then we'll apply joins
okay,
like relations to all tables.
okay,
And if you want, we can create new views
okay,
for required tables.
okay. Perfect. Okay, let's have a quick recap. What are the activities that we do in physical layer over here is, first of all, in physical layer, we will be connecting to a database, that is maybe this Oracle database or some other database that is available, that is provided to us. Okay, after connecting to the database, we will be creating a connection pool to connect to a particular schema, and after creating a connection pool, we will be importing the tables that we need from that particular schema. After importing the tables, what we do is, if you want to create any duplicates or if you want to create any aliases is must, that's the best practice, and everyone used to follow that. Okay, after importing the tables, you will be creating aliases, and we are going to work on that particular aliases. Okay, after creating the aliases, what we are going to do is, we are going to select all that particular aliases, and we are going to right click on that particular selection, and we will be opening the physical diagram, and we will be creating joins, and in joins we will be providing the relationship between both the tables, that is we will be providing them with the corresponding keys, whether with which key both these tables are related, and we will be providing all such particular information. And after that, even before that, we can define keys for each and every alias table. Or else, if you forgot to do that, if you create joins, keys will be created for all the dimension. If keys were not created, we can manually create keys even. I have shown that step even. Okay.
Can you tell me what keys are useful? Like
Hmm?
how keys are useful? What are keys?
Keys are useful is, let us say, let me put it like this. This calendar to products, and now I was trying to create joins between both these four tables. Okay. Now I am clicking on the select objects and all joins. These were not related. The moment I click on try to join between this orders to table and calendars to, it's asking for the relationship whether with what key both these tables are related. If we define keys before moving on to this step manually, it's very easy for us to identify over here. There is no need of keep on rolling here and searching. If we have defined keys already, it will be showing the here as key symbol. Okay.
Okay.
Then it will be easy for us for selection and all. It improves our aesthetic appearance. That's it. Okay. Okay. Our responsibilities here is importing the metadata, creating aliases, and creating joins. Okay. Our duty is if we do all this work, our duty is completed in physical layer. Okay. The next layer and very important layer, that is business model and mapping layer. In business,
One,
okay. Continue with your dot, Harish.
actually, we are saying we have tables and facts, right?
Yes,
Dimensions and
yes,
facts.
yes, yes.
Uh, how to find out which is the fact table and which is the dimension table?
During the first
Dimensions,
process,
we know how to find out the what is how to find out fact table. Multiple tables are there.
multiple tables are okay. What is fact table actually, according to you, as per the demo sessions you have had, initial sessions,
Fact table, um, all the fact table consists of all the
measures,
calculations, measures,
yes,
everything.
measures, right?
Uh,
With that only we will be identifying what is dimension and fact. And fact table contains only corresponding key columns and measures. That's it. We don't have any kind of descriptive things available in fact table. If we just go and view data in fact table, you will get a clear picture whether it is fact or not. Why? Because let us say now here for us d1 orders 2 is fact table. When you view data, we don't have any kind of descriptions anywhere. What it contains is entirely keys. Okay. The entire table consists of only keys as well as measures. That's it. See, no description is available. Or else, if you view such any of dimensions in dimensions, entire dimension consists of hell lot of descriptions.
okay.
This is clear, right? When
Yeah.
when you click on view data, you can easily identify what is what. Okay, this is clear, right?
Yeah.
Okay, let's move on to this. Rajesh is asking some doubt over here. While creating joins, you have selected some columns between two tables. Can we select a column for providing joins or only key columns? We need to select columns that are key columns only, because the column should be common between both the tables, Rajesh. Okay, it's clear for everyone up to here, right?
Yeah.
By this we have covered each and every option that is present over here. That is new object, that is alias or physical column. Alias is nothing but creating a new alias table, or if you want to add one more column for this particular table, let us say new object physical column like Harish. Okay, we can add that column, but that column should be present in database. While if you want to fetch something, then this column should be present with this particular name in database. If it is not there, then we are going to get an error. Okay, this option is clear. Okay, after that, update row count. This is used to update row count in order to see whether any new columns or new things have been updated or not. And the next thing, that is view data. This view data is nothing but viewing data what is that present in a physical database. And this checkout option is useful when you deploy this RPD into online server, and when we open this RPD in online mode, then we need to do checkout every time, and then only it's possible for us to do any kind of modifications. Okay, you will get to know about this in later point of time. This cut, copy, paste, you all know that. This delete and duplicate. Delete is nothing but deleting the particular object. This duplicate is nothing but, as I have called already covered, we will be duplicating this entire structure. If we click on duplicate, it will be a new structure will be created with some additional name to that. That is, if it is like customer to table will get created, which imports all the data of that customer. And this check consistency is nothing but error checking. This is used for error checking. If you want to check whether this table is consistent or not, if you click on check consistency, if there are any errors in the table definition or any structure or anything, then it will throw up with some errors. Okay. Check model. This check model is used for checking the entire model, that is the model that we have designed. This mark is nothing but if you want to mark on, let us say in real time we will be having around 400 to 500 tables. Okay, you are having a problem, and if you want to debug only on some particular tables that are creating problems, if you want to mark them, see, the moment I click on this mark over here, a symbol appeared on it, that is used to mark. Now I have unmarked that. Okay, this is all about this mark. This set icon is nothing but, here instead of this table symbol, we can modify that with any other symbols even, as per your convenience. Okay, that is nothing but set icon. Expand all is nothing but if you want to expand this particular table, if you click on that, then enter table will get expanded, or else we can do that manually from here. And after that, physical diagram. If you click on the select objects only, then only that particular objects will get opened. If you click on the select objects on and direct joins, then only the objects and its corresponding joins will get opened over here. If you click on these objects and direct models with business model, then the entire business model will get opened. If you click on these objects and all joins, the objects and corresponding joins with that particular object will get opened over here. Okay, this is all about this. And query related objects. This is used for if you are messed up with something, and if you want to know what is the parent of this particular column. For all such things, we will be using this query related objects, that is all types. That may be if it is present in a presentation layer, and if you want to know whether to which table it is related to a table in business model layer, then you can click on this. Let us say, see, if you click on that query all related objects, or whatever the tables or columns that we have imported, everything will be available over there. If you want to know what we have something called as this Muslim year over here, and if you want to know what is the parent of that particular column, if you click on the show parent, it will be showing the hierarchy where which it is related. This Muslim year belongs to this D underscore calendar alias table, and this alias table is present in this supplier to schema. Okay, if you want to search anything, then we will be using that query related objects option. Okay, and the last option, that is this rename option, is nothing but if you want to rename your columns, if you want to rename your tables, then you can make use of this rename button. And this properties is nothing but that I have where we do all the other operations, like if you want to design a view, then you will be providing this query over here. If you want to define, if you want to add any new column, we can add that new column manually through from here even. If you want to create a keys, then we can create keys in this keys tab. If you want to create any them as like instead of primary keys, we need, if you want to define them as foreign keys, you can define that here as well. And if you want to have like if you want to declare anything like constants, DSD 45, okay, then we can declare such constant values over here even. Okay, this will be used for reporting, like let us say we have some target value like 500, and we need to refer that regularly, then we can provide such values over here. Okay, but we will not be using this thing much. You can access to these properties as well as through double clicking on table. Okay, And if you people were stuck at any place, we have a beautiful help file that is available. If you want to know what is this, then you can click on F1. If you click, the moment you click on F1, then it will be navigating to this help folder where you can search and you can do your corresponding particular operations. Okay, I have covered each and every option that is available in physical layer. Okay, is this fine for everyone? Or can I move on to this BMM layer now? Okay, now let's proceed to BMM layer. This BMM layer is the layer nothing but it defines the business. In business, this business model layer defines the entire business, because up to here, up to this physical layer, how the data would be present is the data, whatever the things that are visible up to this physical layer, it's all corresponding to database perspectives. Okay, whatever the things that are present here up to this physical layer, everything will be as per database perspectives. Here it is just like table names, whether how these tables were designed and how they were organized in the data warehouse or database. Okay, everything will be present as per database terminologies up to here. But right from the business model and mapping layer, we are much bothered about defining the whatever the things that are present in database perspectives. We need to convert them into business. We need to bring them into business perspective over here. For database people, they are not bothered about business. That is, they are much bothered about what are the tables that are coming to us, how we are processing, how we are saying, how we are saving that particular data, and how the data is well organized for better querying and for better performance. They are much bothered about their duty, that is saving, retrieving. They are much bothered about saving and retrieval. But for a business person is not at all bothered about the technical terms or technical aspects of whether there is a performance issue, whether it's the query is getting delayed. He is not at all bothered. The business people is much bothered about how they are appearing and what if, what do I need from it. That's it. If I am having a particular table, what can I do with that particular table, and where can I use that in? Where can I use that report in my business in order to improve my business? Business people are much worried about their business only. They are not much worried about the technical things. That is what business people look. Okay, in business BMM layer, the much concentration will be done on defining the business. So it is called as a logical layer, or else it is also called as business layer. And this business model is the layer where physical schemas are simplified to business terminologies. Let us say we have something, they have defined it as calendar over here. Why? Because as per technical terminology, they have defined, they have put entire calendar into that particular table, and that is the reason why they used to call it as a calendar. But if business people are more comfortable in calling that particular thing as time. Okay, if business people are more comfortable in calling that particular thing as time, we can rename it over here in this business model and mapping layer. If we rename it over here in physical layer, then we will not be able to get data, because that particular whatever the name that we have provided here is not available in actual physical database. Okay, all the customizations and all the, hey, we can do all whatever the customizations and whatever the operations if we want to do on the data, we can do everything in with this business model and mapping layer. The main purpose of this business model and mapping layer is to capture how user, that is the end user, end business user, thinks about their business using his own vocabulary. Okay, this business model and mapping layer of administration tool contains one or more business models. Let us say here we have only one physical schema over here. From this one physical schema, we can create many business models. That is, the relationship between this and this will be like 1 to many. In this entire administration tool, We can define relationship like this in this entire administration tool. If you have one thing, from this one thing we can create many business models, and from each and every single business model we can have multiple subject areas. Okay, the hierarchy goes on like this. This is complete. After this, each and every business model is also called as data mart. The data mart is nothing but the data mart that is available in data warehouse also. Some data warehouses they are organized from the physical database level. From physical data warehouse level, they will organize data into data marts. And so if you were placed in such projects, it will be very easy for you guys to understand how the data is organized, and it will be easy for you guys to work on that. But in real time, that scenario will not be possible, because initial phase they will design as per data marts. But if after the business keeps on running, they will be facing they will be coming up with new requirements, and depending upon their time constraints, they will not be bothering about all the business principles, and they will just be more concentrated on their own work. So that actual business model will get disturbed at many times. Okay, now let's work on practically whether how, what, and what are the operations that we are going to perform in business model and mapping layer. In order to create a business model, what we need to do is just right click and click on new business model. Here we need to provide a name. Let us say I'm having business model like sales. I'm creating a sales business model over here. In this sales business model, I want to have a table called as time logical. Let us define that logical table as time. Click on OK. This is empty over here. Okay. In this particular time column, sorry, in this particular time table, I need data of this corresponding calendar too. And I am purely an US customer. I am purely an US client. I don't need all these Chinese things. I don't need all these Muslim month, date, year things over here. Okay, I will deselect all these things. Okay, among these, I don't want this. I don't. I just want. I'm just eliminating all the unnecessary columns over here, and I am importing only useful columns into my logical table. Okay, here under this source, till now we don't have anything under this source. Okay, the moment when I drag and drop all these columns over here under this source, we have plus symbol over here, right? If you open that, see, a component has been created over here. This component is nothing but, we call this as logical table source. While creating a table, what we have done here is we have created a logical table. Okay, for that logical table we have provided these particular resources. Okay, these resources belongs to this particular physical table. Whatever the objects that we have provided to this particular logical table, all these things belong to this particular physical table. Okay, in order to define the relationship between both these things, we need to have an address, whether where what is the address of this particular in this physical, what is the address of this particular logical column in this physical table. Okay, that address will be defined over here in this logical table source. When the moment you click on, double click on that, you can see the details, that is its address details. Okay, it is connected to this ORCL1 database, and in that supplier 2 schema, and in that D1 calendar 2 table. Okay, this is how we can define. Now for my convenience, what I have done is I have just dragged and drop all these tables and columns here, right? I can even create them manually even, that is new object logical column. You can create a logical column manually, and then you can import data from whatever the physical table, physical column that is available even. Okay, you can do these steps in whatever the way that you are as per your convenience. This is fine, right? Or else let me say, if you want to, okay, let me create one more business model. I am creating, uh, I'll be doing in this business model entirely through manual process, and I'm going to create one more business model. And in this business model, I am importing everything through drag and drop. That is, without using any kind of manual operation, without doing any kind of manual operations. Okay, let us say it is automatic. Here, these are the tables that I am using in the project for now. Okay, I'm importing all these tables into here. Okay. The moment I import all these tables here, then everything will be created as we have already defined joins over here. For this particular business model, everything will get automatically imported from this physical layer. If you click on this business model diagram and whole diagram, you see even joins have been created. But we'll be getting some doubt. We have already joins in physical layer and we have imported. Then what is the use of joins, creating a joins again in this BMM layer even? Okay, I will show you the difference exactly what is happening over here. If you open the logical join here in this business model diagram, previously the diagram is called physical diagram. Here the diagram is business model diagram. If you open this joins, any join in this BMM layer, some other options will get enabled over here. That is this driving table. Okay, this driving table and type of the join. Previously, we don't have any option to define whether that join is an inner join, outer join, left outer, right outer, or full outer join. But here we can define that relationship. Okay, here we can define such relationship. We can define all such relationships over here in logical join. And the other thing that is possible in this logical join is cardinality. Cardinality is nothing but the type of relationship that exists between these tables. Here it is fact table. That is this F1 orders is fact table over here. And we have dimension D calendar. In dimension, the value, whatever the columns or whatever the rows, that will not change very frequently. That is, each and every single record in this dimension table will be used multiple times with with whatever the records or whatever the references that are present in the fact table. Okay, each and every single thing is related to multiple records. Let us say we have a customer over here, customer details. Okay, this customer has purchased 10 products. Okay, all these 10 records will be available in fact, but the customer details, that is for a single customer, only single record will be present. Okay, this single thing is related to this multiple transactions over here in this fact table. Okay, this relationship is nothing but cardinality. This one thing is related to many things, that is n in this particular fact table. We are going to provide such relationships over here even. Okay, this driving table is nothing but here this driving table concept is used to improve the performance. Here we will be providing a reference of a table that contains very less number of records. Okay, here we will be providing a table with very less number of records as driving table, because then the query will get driven with that particular table and the performance will get improved. But as per OBA best standards, it states that if the number of records in a particular table that we are selecting it as driving table is more than 1000, it's better not to select the table as driving table, because the driving table is just used to improvise the performance. If we provide a table that is having more than 1000 records as a driving table, it's of no use and it may create some complexities even. Okay, as a best practice, so if we are having records where, like less than 1000 records, then only we will be selecting that particular table as driving table. Obviously we can't select fact table as a driving table. Why? Because fact table contains hell lot of records. As a minimum, lakhs and lakhs of records will be available in any fact table. In general, we will be selecting driving table as a dimension table only, but we need to take care that as per OBE standards, they state that if it is if the number of tables, if number of columns in driving table is more than uh, number of records in a driving table is more than 1000. Records means rows. If number of rows, that data rows is more than 1000, it's better to avoid providing driving table for that kind of tables. Okay, all these other functions will be defined here in this logical join relationship. In logical join relationship, all these functions we will be performing. Okay, it's clear up to here, right? Here we have dragged and dropped from here directly, and we are using that particular things over here. Each and everything got imported from this physical tables. Now I will be showing you with the manual process. I have created this time. Now I am going to create another new logical table, and I am providing name for that logical table as customer details. And for customer details, I just want in customer details only customer name, new object. I am going to create a logical column. Customer name, and one more logical column, that is customer region, and one more column, that is key column, new object, logical column, customer key. Now I have defined the structure only, but I have not provided the source for any of these, the particular column that I have defined. Now I am just creating each and everything manually over here. Now let me select to which table it should related to in the physical layer. Here in column save, column source, I can select see, for the column source I can provide all the sources here. If you want to derive from physical mappings, you can derive it from physical mappings. If you want to derive it from something, from any columns using an expression, you can derive that as well. Okay, in order to provide such relationships, what we can do over here is, here we can add sources. When the moment we click on this add button over here for that particular table, here we have all the customers. See this D1 customers 2, or the alias D1 D underscore customers. Okay, we can select that particular thing over here. The moment I click on this particular selection, it came to our logical table source. We need to provide logical table source name over here, that is LDS underscore customers. Now I have created everything large. It's just displaying an error like what these particular columns are not having any kind of mappings, because I have till now I haven't defined any source here, right? So mapping has not been created for this particular column. Now I am going to create a mapping to which table this is related to. See, now this particular LTS customers is available for me now, but I don't have any kind of mapping. When the moment I click on mapping, here when I click on this show unmapped columns, all these columns were unmapped. For this customer key, I need to map this customer key to this new key. And customer name, I will be naming this customer name to name, and customer region, that is region. Okay, now I have created each and every component that is present in this particular, from the logical table to the bottom component, that is logical column. I have created each and everything manually over here. See, now everything is perfect over here. If you want to define this thing as a key, even you can do that. That is from here, key. If you want to make use of something, if you want to customize anything, you can do each and everything over here in this business model and mapping. Okay, see, now it is available as key column. By this you guys came to know whether how we can import things, objects or things directly from physical layer to BMM layer, and or else if you want to create them manually, how we can do that. Okay, this is fine, right? And for the rest of things, I will be doing direct drag and drop, because it consumes a lot of time. Okay, I have imported this time, I have imported this customer data, and this time is related to what logical source, general. Okay, I'm sorry, I'm deleting this time. Why? Because I'm pointing it to this, I'm not pointing it to this alias table. Okay, now I am importing this calendar to this, as well as now I am importing products and orders. Here I have defined this join and relationship completely here, right? As I have imported all these things, even here the relationship got created here. When I click on whole diagram, the entire relationships appears over here even. But if you as I have shown this manual procedure, right? If I click on if I do each and everything manually, then we need to create these joins even manually. Why? Because as I am defining the entire structure manually myself, I need to create these logical joins as well there. By this we come to know what are the operations that we can do. These are nothing but initial operations. We are going to discuss about this business model and mapping layer for another two or more sessions as well. Why? Because we need a lot of topics to be covered in this business model and mapping. These are nothing but the basic importing operations, whether how we can import. Okay, till we are just importing data of a single particular table in physical table to a single particular logical table in business model. But we have other options as well. That is, for a single table in this business model layer can get data from different columns in various physical tables that are available in physical layer. Okay, all such advanced operations and all the other things also we are going to know about them in our coming sessions. Okay, till now what we have done is we came to know how to create a business model and how to import data into that particular business model. Okay, our import part is complete over here. After importing uh, we need to uh, we need to provide information to the logical table that what is the measure over here. We are having keys as well as measure columns over here in this fact table, but we need to provide data to that whether what is the measure or else. Okay, here it is ACTL EXTND. This is as per the business terminology, as per business, sorry, as per database terminology. ACTL EXTND means actual extended dollars. But if any business guy look at it, he can't understand what is that. Okay, if you want to rename that particular thing as dollars over here, okay, we can rename that manually over here, but this thing will be referring to ACTL EXTND in the physical layer. Okay, the physical layer source will not get changed, but here as per our convenience we'll just keep on changing the names and all the other things as per our convenience. Okay, now actually what we are discussing is here for the fact column we need to define which one is measure. Why? Because I will show that to you practically using the other RPD that is that we have designed previously. What is the I will be showing you guys what is the use of aggregation. Go to this analytic page. Don't concentrate on all the things, guys. I will be discussing each and everything step by step later, but I just want to show you whether what aggregation is and impact of aggregation. I just want a report with region, year. Let me say I will just use region only, customers region and XCTL XTND. If you click on results, what's happening over here is for in every central we will be having many transactions. It is displaying each and every transaction individually. It is not getting aggregated. The data is not getting aggregated over here. Each and every individual data is getting displayed over here. That is what it's happening over here. See, for central it's displaying all this data. Okay, it is getting displayed like this because I have not done any kind of aggregation over here. If it is aggregated, all that things will get grouped together. If we show to the tool that this column is particular column is aggregate column, it perform aggregation operations like it will sum up all the individual data that belongs to this central region. Okay, the summation activity will take place if we define any particular column as aggregate column. Okay, let me show the difference how if I define it as an aggregate column, how the data gets populated over here. Okay, I am opening this BA administration tool. As I have deployed this particular RPD into this server, I am opening whatever the thing that is present in the server. That is, if I want to do modifications on whatever the thing that is loaded into the server, then I need to open RPD in online mode. Okay. File, open, online. I need to provide repository password over here. Open. The moment I click on, now I have opened that particular RPD in online mode over here. I have opened that particular RPD in online mode. See, the difference can be observed over here. Here it will get displayed like online. In this particular supplier to schema, and for this orders to, I have even here I have not provided aggregation rule over here. So let me rename this as per the customer's convenience. If you want to do any kind of modifications in online RPD, what the first thing we need to do is we need to check out. We need to check out whatever the particular component we need to do modification. If you want to check out for entire RPD, you can do this through file checkout all. Okay. If it is checkout, it will be shown with this symbol, that is this tick mark. Now I am editing this. This ATCL extend, I am renaming it to dollars, and I am defining aggregation rule over here. I am defining aggregation rule as sum. The moment when I define aggregation rule, then it will read that column as actual measure column. Okay, the moment I do such operation, see, now it's showing as measure. It's not getting displayed properly. Let me check in. Okay, see, now it is displaying as measure. Okay, after after defining aggregation rule on this particular column, now you guys can watch the difference, how it's going to impact in the report. I have done all the checking changes. Now go to my analytics page. Let me refresh my data. Refresh server metadata. Okay. Let me create this report once again. Customers, region, and see, now it's treating it as a measure, an aggregate column. The moment I click on results, now you can see that, see, this is what the actual data is. This is what actual data need. The manager don't need data of each and every individual village and town that is present in central region for his analysis purpose. The manager will just look at how is the performance in central region, how is the performance in east region, and how is the performance in west region, and he is going to poke the corresponding his subordinate who used to take care of central. If he seems that central business is not working properly, he'll be questioning the central guy. He will not questioning the guy who is at the utmost bottom level, that is the any sales representative, that is who is to take care of particular 3 or 4 villages and all. Okay. This is the actual data that we need. That is the data that we need here at high level is aggregate data. You can see the difference easily over here, right? Okay. For each and every fact table, we should define what are the measure columns. Okay, we need to provide information to that, what are the measure columns that are present in that particular fact table. Okay, in business model and mapping layer, we are going to define that structure as well. In the business model and mapping layer, we are going to provide identification to the tool that what are the dimensions and what are facts, and in facts what are the keys and what are actual measures. Okay, now let me do this operation once again here in your RPD that I am practicing. I am providing aggregation rule as sum. Okay, now this is complete. Up to here I have done whatever the corresponding operations on business model and mapping layer. Is this clear for everyone over here? Okay. I am going to end the session with one more topic. It's very small topic only. In the particular with this business model and mapping layer, if you want to do any kind of calculations operations, let us say we have some simple calculations. If we have a calculation that is subtraction of this particular column data with this particular column data, and if you feel like this data will be usable only for a particular report only, if that particular data is available only for a particular report only, then there is no need of placing that entire data in database level. Okay, if you are using that once again, if you have some repetition users, then it's better to place that in database. Why? Because it's going to kill our performance of our BA server, as we are using some particular data only in some particular tables only. Then we can create some calculated columns over here in this BMM layer. Let me show an example of with this both these tables. Let me define the aggregation first for these two tables, that is sum, and for this as well sum. Okay, now I just want to create, this is nothing but unit shipped and this is nothing but units ordered. I just want to create a column that is pending orders. That is, pending orders is nothing but the unit orders minus unit shipped gives the amount of pending orders that are pending, that are the orders that were not shipped. Okay, in order to do that, I will right click on my logical table, go to new object, click on new column. Now I am creating a new logical column. Let me provide name for that particular logical column. I am providing name for it as pending orders. Now I need to provide source. What is the source for that? We can define that from this physical source, or else we can define from existing columns using an expression. We already have these two existing columns over here, that is units ordered as well as unit shipped. I'll make use of both that things and I will be creating this new column. After clicking on derive from existing columns using an expression, you will be having a calculation button over here. If you click on that calculation button here, it's showing category of tables that are available, that is logical tables, operators. Operators are nothing but the any operation that you need to apply on that particular logical tables. First of all, let us select logical tables over here, that is orders logical table. In that particular orders logical table, I need this units ordered. Okay, units ordered. After selecting this particular column, click on this insert selected item button, and it will get inserted here. Here we have the main operations that are plus, minus, into, divided by, and or not and all. Okay, here among this I need minus unit ship. Now I get data of units ordered minus unit ship. I will be performing this particular calculation in this particular column. The moment I click on OK, I will be getting a new column, that is pending orders. Okay, let me do the same thing and I will show that to you practically within just matter of 2 minutes, and I will close this session for today. Okay, I will be doing the same operations in this online RPD as well. Checkout. Okay, let me do checkout for each and everything instead of doing that for each and every individual component. Let me check out all. I am not defining aggregation for this particular column and this column as well. Now I am creating new logical column, that is pending orders, and I am defining the column source that is from existing columns, and in this these columns are present in this orders too, and unit is ordered minus this unit shipped. Okay, now the expression for this column is ready, and it will, at the moment I click on OK, it will perform its calculations internally, as I have already defined measure for both these columns. And as this table is getting calculated through these measures, it will automatically populate it itself as a measure. Okay, aggregation will get automatically created on this particular table, and this aggregation tab will also get disabled over here because I am calculating that particular measure from the other measure columns that are present in the logical table. Now I have created this new column in this physical, sorry, in logical table. Okay, as I have created this new column here, this will not be available in this presentation. I need to import that into this presentation layer. Okay, now I have imported this particular thing into presentation layer. As I have imported this, the moment I click on check-in and the moment I click on refresh, this column will also be available in our front end page, in our analytics page. Click on check-in. Okay, now let me open on my page. See, actually previously I have defined aggregation only for dollars, so only dollars is displaying as aggregate, and these two are also getting displayed like normal columns. The moment I click on refresh, now see all my new column also came here. Okay, let me generate another report. Okay, I will add these particular things to this report only. I'll be using this units ordered, unit ship, and pending orders, and click on results. See, units ordered minus unit shipped is nothing but this value. This is our calculated value, and this value get calculated using these two columns, and it is displaying. If you want to cross check that even, you can cross check that. That is 54666 minus 529587. It is 17076. Fine. Okay. Is this fine up to here, guys? I have covered up to creation of logical columns and creation of calculated columns in BMM layer, and we have many other important points to discuss in BMM layer as well. Okay, I am going to cover up them step by step in our coming sessions. Okay, is this clear for everyone up to here? Harish?